going to do volumes today. Okay. You know what? We're going to do volumes today. We're going to create them by rotating curves around axes. And there are three methods that we're going to use. We're going to do the first two today. And there'll be some tricky ones. You're going to have questions. You really need to work on these problems because this will be a problem on the exam. It's always been on the exam. And they might change it, but I've never seen it yet in 20 years. So you know you're going to have one of these. We're going to have cross sections that are discs, like a quarter. But we kind of have a washer from somebody's watch. Then we're going to have cross sections that are like washers. And then we're going to have cross sections that are going to be usually squares. It could be rectangles like a deck of cards. If you open a deck of cards, you take one card, there's your cross section. But they're all the same in a deck of cards. They don't have to be, though. I just thought of something. But okay, great. Now, you guys, the shell method, Jack, is extra credit if you want to do it. You have a little quiz on it. Okay. We're not doing that. We're going to create solids like a football, okay? And we're going to slice it and add up the slices. Okay. And you're basically going to use the cross-section of the solid. So the first thing on your steps is sketch the solid in a typical cross-section. Then find a formula for the area of your base. And it also should say find the differential, because that tells you the variable. And I see a lot of tests without the differential, but then my question is, how do you know if it's X or Y in the problem? Differential always tells you what it is. Find your limits of integration and then integrate. Okay, so let's just do the problem. First, we're going to graph it, and some of you may not know how to graph that. And we're going to graph this function. What is this shape? Minus x squared plus 4. It's a parabola, but what's special about it? It's upside down. We're going to bound it by that region, the x-axis, the line x equals 3, and we'll rotate around the x-axis. So I'm going to leave myself some space so I can rotate around the x-axis. Well, we have to figure out how to graph that. We know it's a parabola, it's upside down, and it would be nice. It would be nice if we had some intercepts, like if x is equal to 0, y is equal to what? If x equals 0, what's y, Zach? 0. Okay, what other kind of intercepts would you like to find? Then y equals 0. Now, generally speaking, I think they're going to give you the picture. I can't guarantee it. But 0 is equal to minus x squared plus 4x. How do you solve that equation? Colin, how do you solve that? Good. What am I going to factor out of it? What 2's? There's no 2's there. Okay. Factor out at x, what's left? Well, there's a 2 right there. Okay. Factor out 1x is minus x plus 4. Hey, guys, this is getting ready for the exam. Okay, Samuel? How do I get what? These are the intercepts. So what's x equal to? 0 or 4. Okay, you need to draw this. We know it's a parabola. It's going to look like this. And there's a 4. We are going to bound it by the curve itself and the line x equals 3. So I'm just going to do my own x equals 3. I was going to put a line there. And the x-axis. So I want this region right here. And I'm going to rotate that around the x-axis. No. There it is. We're rotating it. So we're going to take our curve, and I brought in some models to help you. Except I should have brought an apple in. Hey, guys, brackets are later. You only have 2 lessons, today and tomorrow. That's it. We're done. Then we will spend this week and next week reviewing all this material, and we will leave this behind, and you will have to study it before the exam. Okay, so here's my solid. Okay, guys, watch. And I'm going to rotate it. I'll talk about that in a second. I'm going to rotate it all the way around 360 degrees. That's my shape. Or I could use this shape. You guys have seen this stuff. Trick or treat. Okay. I'm going to rotate this around the axis. See how it becomes three-dimensional? Now, if you slice it this way, what's the shape of the base? It's a circle. So now I'm going to do my best to draw this thing. First, I'm going to color it. Any particular color you want? Purple. The only reason why purple's bad is it'll be hard to show up what I want to draw, but that's okay. Okay, ready? Maybe the green will be nice. Okay, guys, we're going to slice this, and you're going to get a disc. The cross area of the cross section is a circle. Now, everybody should have this drawn, Jack. Everybody should have that drawn. Okay? Casey, you got it drawn? Because if you don't draw it, you're never going to figure out what the radius is. Now, this is an easy one, but they're going to be harder when you look at the AP problems. Question in the back? I have to figure out how to do it. Well, I think there are files for it, and I forgot to look at that over the weekend. So there's my disc. And it looks like a very short cylinder. Not very tall. Is that delta X or delta Y? Which axis does it hit? It's delta X. Yep. That's the easy way. Okay? That's delta X. So I want to find the volume for one of these cylinders. We're still drawing over here. You didn't draw, Jack. You really need to draw. I don't know why this is doing this today. Okay. Volume is equal to pi radius squared times the thickness. Samuel, what's the thickness? Delta X or delta Y? Guys, all you have to do is listen to me for 2 more days, and then the rest is just doing problems. Okay, here's the radius. Let's see. Can I do that? I want to change color. There we go. Maybe we could try a crayon. Let's try a crayon. Well, that's not very good. Can you see the radius? What is the radius, you guys? Okay, Casey, what's the radius? Guys, you need to be quiet. Do the problem with me. Well, it's y1 minus what? 0. It's this y coordinate right here. Okay, Declan, you get this? So what's this become? No. Radius is y1 squared n times delta x. And then what are we going to do with these? What are we going to do with these, Lauren? All I did, you guys, there's no calculus here yet. I took a slice. This is geometry. I took a slice of this apple. If you were just to slice it, you'd get a circle, right? And you want to find the volume. The thickness is delta x because this is the delta x distance. The radius is the y coordinate of my curve. Okay, guys, Stephen? If you're not listening, that's your thing, but I need you to be quiet. Okay, so what are we going to do? It's the area of the circle times how thick it is. That's all it is. This is the area of the base times the height of my cylinder. That's it. Here's the calculus. We are going to integrate that. We'll pull the pi out in front, and it's y1 squared dx. That's the calculus. Finding the integral. Well, oh, wait, I got a problem. This says dx. They don't match. They never will. So you're going to have to take your function and solve for y in terms of x. But I already know what it is. It's that. You are safe. Okay, it's what? Minus 4x plus x squared?
Minus x squared plus 4x.
Oh. I'll fix that. Minus x squared plus 4x. And what are we going to do with that? It's the radius squared. Now, this is the easiest thing. Okay, Stephen, you need to sit someplace else. This is the easiest thing we can learn for the exam. This is always on the exam. They're easy 9 points for the most part. This is where you're going to get your points. You got to get your points where you can. This and differential equations are the places you get your points. Okay, what are the x's going to go between? Grace, what are the x's going to go between? Guys, this is it. Today and tomorrow. That's it.
What's the differential?
0 to 3.
An equation involving differential answer is a function. Well, that's what it is.
Okay. Can you integrate that? I can't integrate it unless I square it, because if I do a u substitution, and u is equal to minus x squared plus 4x, then du would be equal to minus 2x plus 4 dx, and I don't have a minus 2x plus 4 in there anywhere, so it's not going to work. So we're going to use our calculator, but you could square it, but we're going to use our calculator to remember how to do that. And you remember it's going to be, now this is what we want to see on the exam right there. You will get a point for the limits of integration and the pi. Don't forget pi. On pi day, you guys forgot to bring pi. Don't forget the pi. Then you will get a point for the integrand. Even if you forget the x, you still get your point. And then you get a point for your answer. So there's 3 points per problem. Same with the area. Generally speaking, that's how it is. Now, if you, I don't know what's going to happen. If you make a mistake on these limits of integration, you lose that point, but I also believe you will lose the answer point because your answer will not be correct. I don't know. It depends. It's from year to year. Yes, you still get 1 point. You get nothing. Question was, what if you put the answer down with no work? You get nothing. Okay? Nope, you have to have the work. So I'm going to get my calculator out. And mine's probably already set up because I just did this problem. Oh, no. That was not the plan. Okay, ready? Okay, guys? And we want to put in y equals minus x squared plus 4x. I did that already. Where's your calculators? You need to be bringing your calculators. We will be practicing problems. You know that this problem is almost always a calculator problem. Just 2 years it wasn't. It was in 2010 and 2011. It was not a calculator problem. You can put the pi in or you can leave it on the outside. I'm going to leave it on the outside. Pardon? Answer is 10.6. Did you square it? Okay. Are you ready? Okay, we do math. Okay, Declan? I'm going to attach it at the end. Okay, guys? Math 9. Now, I'm going to put, it's pi r squared, so I'm going to put the radius in, which is y1. And it matches right here, if you think about it. It is really nice. Plus you have a shortcut to the y values. Okay, y1, and I want to square it. So that's where I put my squares, right there. Because it's the radius squared, comma, then it's delta x, comma, and we're going from 0 to 3, right? 0, comma, 3. $30.6.
I got 9.
Did you square it? Oh, we'll get that. Did you square it? Oh, if you put pi in, it's 30.6 times pi, which is approximately, what is it with the, if you, no, 96 point, I got to have 3 decimal places. 132. Some of you guys got 8s because you, this is exact. 30.6 pi is exact. It's fine. This one is an approximation, and you must have at least 3 places. Better to have too many than not enough. You'll get 30.6. Why would I want to do that, though? Oh, just, it's exact right there. I don't know. Let me see. You guys, turn the page and try and draw the next one.
Yeah, I do.
Oh, you don't.
Yeah, I do.
So it's saying divide by 0. No, I had to.
Because you don't have your a in there, your function in there. Okay, let's try this one. Okay, you guys know what this looks like? X equals 2 over y. Okay, what does that look like? X equals 2 over y. X equals 2 divided by y. Well, x times y equals 2, so y equals 2 divided by x. Do we know what that looks like?
Yeah.
Yes. Okay, you guys should be drawing this. I'm going to bound it by, I could, but I'm going to be bounding this by the line x equals 0, which is what? Yes. The y-axis. So it's only in the first quadrant. Sometimes we do go to the second quadrant, but not today. Okay, so now I want to get my lines in here. The line y equals 1. Y equals 4. Whoops. I know, I'm going to fix that, don't worry. Okay, guys, draw this. Okay, so we're in this region right here. No, I don't want to do this. 84. Okay, there it is. Okay, guys, I don't see it drawn yet. You need to draw because you are not going to necessarily know where the radius is. So I'm going to take that and flip it and put it over here. It's not great, but whatever. So it's just this part here. Let me color it. It's this region here. Oh, Bella, but there's a top's not there. How about a volcano? There's different kinds. Okay. What does the cross section look like? It's a what? The cross section is this piece right here. It's a circle, right? Oh. Okay, it's not going to let me do that, so I'll just do this again. Okay. Now, when you draw your radius, okay, guys, when you draw your radius, okay, guys,
But I have a quick question.
yeah,
Wait, so you just connect these two bases that are two points right now?
up at the top, I made it's a circle
Why?
because it stops there. If you slice it, it's a circle.
They could just take the top off.
Now, when you find the radius, okay, guys, when you find the radius, you go from the axis of rotation to the curve. What's the radius equal to, x or y? It's x. Okay, do you guys get that? Jacob?
Yeah, I get it.
What's the radius equal to? X. No, just x. No. Okay, Zach, what's the thickness here? The delta x or delta y? Which axis does it hit? This distance is the change in what? Y. You see that? Okay, Jack, what's my formula going to be? The volume equals pi, it's the area of the base. What's the radius?
X squared.
It's x squared, and then it's delta y. These are always going to be opposite. If you learn the shell method, they'll always be the same. But it's not on the test, so you never have to use the shell method. It's extra credit. No, it's actually, I like it, but it's hard in the beginning, but after once you get used to it. Extra credit. Okay, so let's do this. Ready? Now, I'm going to have to I'm going to integrate that. I'm going to pull the pi out in front. And it's x squared dy. What variable do you want in this from? Want x's or y's? I want y's. Because of the dy. Okay. It's already in the right form. X equals 2 over y. And we are going to do this one. And what are the limits of integration? We'll have 2 points then. Now, this is very typical for if this problem were on the non-graphing calculator part of the exam. Okay, girls? So what are you going to integrate from? The y values start where? You're going to start here. Y is 1, and it's going to go up to 4. Well, I want to integrate this. You wouldn't be expected to integrate this by hand. I want to do this because, without the calculator, because some of you integrate this wrong. First thing, let's square that out. What's that going to give you? 2 over y quantity squared is what? Jack, what is it? 4 over y squared. Okay. What can you do with the 4? Pull it out in front. Okay, so volume equals 4 pi of 1 over y squared dy from 1 to 4. Here's what a number of you want to do. You want to make it a natural log. It's not a natural log. What? No. What would it have to look like to be a natural log? It would have to be the integral of 1 over y dy. No use substitutions. Okay? That's the power rule. Okay, guys? The power rule works for everything except when the exponent's negative 1. Because I pulled this 4 out. So this is 4 pi, the integral of y to the negative 2. Okay, Jack? What's that going to give me? Do you know it, Jacob? What's the antiderivative of y to the negative 2? Negative 1 over negative 1. Evaluated at 1 and 4. Some of you are creating your own notations. They'll be marked wrong on the exam, so don't do that. A lot of things I've never seen. Okay. I want to get my answer point. I don't care if I have it simplified. We will simplify it, but to get the answer point, guys, it's 4 to the negative 1 over negative 1 minus 1 to the negative 1 over negative 1. That will give me my answer point. If I mess it up from there, I'll take it back away from you again. So we don't want to do that. You can just leave it. We're going to simplify it because we're not taking an exam. So this is 4 pi. This is negative 1/4. And these two negatives will cancel out. Plus 1. What's 1 take away a fourth? 3/4. So the answer is going to be 3 pi. On the arithmetic? The 4 to the negative 1 is a 1/4. And I understand why you have problems with the negative 1s. Because, you guys, this means, Jacob, this means inverse sine. This means the reciprocal of sine. So the negative 1 has two meanings. You have to figure out which one they're talking about. But these are reciprocals right now. Hey, girls, question? Okay, we're ready to try the next problem.
Yes, we are.
Graph it. You got to graph it. I'm letting this sit here for people who still need it. Is everybody done or not?
We're ready. What happened to the little whiteboard and stuff?
Okay, shh. I cannot hear Colin because you guys are so noisy. What? I want to show you that it wasn't the natural log of y squared. Still, a number of you want to make that the natural log of y squared. How do I know it's not the natural log of y squared? Take the derivative. What is the derivative with respect to x of the log of x squared, y squared, star squared, who cares? First off, I would make this the derivative with respect to x of 2 log x. Okay, Grace. Then what do you do with the 2?
Pull it out.
So that's 2 over x. Is that 1 over x squared? No. Just showing you log is only for 1 over x to the first power. Because I know I'm still seeing that. Okay. We really don't have enough, I don't have enough space here. But we're going to do the best we can, and I will just work down past that part, and then we'll just do the second part. So there's 2 parts to this. There's 3 problems left. And the first challenge is going to be graphing this. And we're going to rotate this over the x-axis. Well, y equals x squared is easy. Okay, girls. Then y squared equals 8x. What does that look like? Casey, do you know? Y squared equals 8x. That's a parabola on its side. Can you solve for y?
Yeah.
You square root both sides. So the absolute value of y is equal to the square root of 8x. So y is equal to plus or minus the square root of 8x. So that would look like this. Where's the intersecting region? Want me to put your phone away? Okay. I'm sorry, what? It's this region, which I'm going to erase, actually, right in here. Right? Well, actually, it might be a... And then I want to rotate that. Okay? Good, he's drawing that. We're going to rotate this around here. Now, you got to be careful with this one. Is that in the right place?
Yeah.
It's okay. Not great. And then we're going to slice it vertically. That's a good question. Because if you try to slice it horizontally, you're going to get a weird shape. And you won't get both pieces there. It says where to flip it. No, it says rotate it around the x-axis. Well, it's a three-dimensional picture.
Whatever the green for.
I'm showing you the slices. What do the slices look like? The slice looks like this.
Oh, it's a walk.
Yeah. Oh, a CD. That's even better. Because there's a hole. This is empty in here.
Like a volcano.
This is empty in here. So this is called a washer. So if I want the volume of a washer, Grace, how do I do that? Hey, you guys, you're too noisy. If you're not interested, that's one thing. But you can't be chit-chatting, Jack.
Whoa.
How do you find that? You find the volume of the big cylinder minus the volume of the little cylinder. And is this delta X or delta Y? Jack, what is it? Which axis is it hit? That's delta X. Okay? Is that the same as pi r minus little r quantity squared delta X? Are they the same?
No.
They're not. Because this is subtracting first. Let's factor this out. What does this look like? This looks like pi. It looks like r squared minus little r squared delta X. I'm asking, are they the same? Is r squared minus little r squared equal to r minus r squared? No. You cannot distribute that exponent, but that's the classic mistake. That's what a lot of people want to do in the exam. They want to do that because it makes it a little easier to do sometimes. Okay, so what's my radius? This is the hard part now. What's the big radius? You go up to this curve. That's the which coordinate, y or x? What? No, this is wrong. This is not the same one. Put a big X to it. This is y1, right? What's the little radius? The other y value. Call it y2. So capital R is equal to y1, and little r is equal to y2. We'll do this one in a moment, but I'm just going to work down here. So I'm going to get pi big radius squared minus little radius squared delta x. And now I'm going to integrate. That's just for one of those washers. And these are washers, right? They look like this. There's a hole in the middle. It's not solid. As we come into Easter candy. Yes. So we're going to integrate. Let's pull the pi out. And it's the big radius squared. So it's y1 squared minus y2 squared. And what's the variable we want? Guys, what's the variable we want? X. The differential always, guys, the differential always tells you what variable you want. So I need to have y in terms of x. Now you got to go back to your picture, which is the big radius. Which function? It's this one, right? That's the square root one, which was, I want x's in here. Y squared equals 8x. So what's y equal to? The square root of 8x, just the positive one. So this is going to be the square root of 8x, but we're going to do what with it? Square it. Minus, and then I want y equals x squared. The little radius is y equals x squared. So it's x squared. Have we squared it yet? No. That's the y value, and we're going to square it. So is it easy to get it mixed up? Yes, it is. And unfortunately, if you don't get the integrand right, I don't know if you're eligible for the answer point. Probably not. And the x's are going to go from, we have a problem here. Nothing. We just have to figure out where they intersect. No, it's not. Let's pretend it's a non-calculator problem. Y equals x squared. Well, not quite that. And then what's the other one? Y squared equals 8x. Probably weirder.
I don't like these words. I don't understand.
Find the volume of the solid created by rotating shape, this shape around the x-axis. Guess what we're going to do for problem 2? We're going to rotate it around the y-axis. That's what this is. You've got the copies of all the exams. That's your homework. Do those problems, and we have a lot of time to work on them. The only thing you won't know how to do is the square cross sections. But guess what? We have to figure out what the x values, where those intersect. Can't I take this y here and put it in for that y? Then I get x squared, but it's squared equals 8x. No. Y squared equals 8x. So that's x to the 4th equals 8x. To solve any equation, I set it equal to 0. Some of you might be able to look at that and tell me right away what the answer is. Minus 8x equals 0. I'm going to factor out what? X. Then it's x cubed minus 8 equals 0. So either x equals 0 or x cubed equals 8. So that means x equals 2. So we're going to go from 0 to 2. This is algebra. You set every equation equal to 0. It's how you solve them. Can you do this by inspection? You're just looking at it? Yes. Or you solve it. X cubed equals 8, then you cube root both of them, you get 2. We still have 2 problems yet to do. Guess what? We're going to take the same region and rotate it around which axis now? The y. Okay. No, part B says y-axis. So draw your picture. I'll get mine ready too. Oh, we didn't integrate it. You can integrate that on your own if you want. Now this would be done by hand. Because that's just 8x. That's x to the 4th. It's just a power rule. It's easy. No, the integral adds them all up. It finds the area volume of every little washer that makes that figure. So this would be 8x minus x to the 4th. That's easy to integrate. It's just the power rule, isn't it? That's 8x cubed over 3, x to the 5th over 5. Yeah. Right. My focus right now is to get these set up. So you should be drawing this next one. I'm going to draw it. And we're going to rotate across the, what, y-axis, right? Okay, so it's this region right here. There we go. Kind of looks, actually, it almost looks like a rabbit ears now. Or a flower. So let's color it in. And then we'll slice it. So it's open at the top. But here, it's a washer. Can you see the washer now? And that's me. The fun part is drawing these things. Because if you slice it, an apple, depending on which way you slice it, you can get circles. Don't you? We can see it's hollow there. I just have the green. Yeah, this is where the problem is. This is geometry. Okay. So we'll draw in our radii. This is the little radius. And then we have the big radius, which goes over to that function. Okay? Which values do we want, x or y? x. We'll call this one x1. We'll call this one there x2. So how do you find the volume for one of these washers? It's pi big radius squared minus pi little radius squared, and what's the differential? Take this is second part. 3b. What's the differential? Delta x or delta y? Because that tells me what variable I want. So it's going to be pi. The big radius is x1 squared. Little radius is x2 squared. Delta y. I don't want to see x1 minus x2 quantity squared. Never. And then now that's just for one. This is the volume for one. If I want all of them, here's the calculus. We'll integrate this one. x1 squared minus x2 squared. Getting this set up is geometry. Which variable do you want? Yes, you do. No? You want y. The different. It always tells you, and these are always opposite.
I think it uses substitution.
No, we haven't gotten to that yet. Okay. Now let's see. X1 was this one, you guys, which was y equals x squared. So what's x equal to? Square root of y. That's the first one. Let's see. This is the square root of y squared minus, and then the other x is that was it y squared equals 8x? So you have to solve for x in terms of y. So what is that? What's x equal to? Declan, what's x equal to? Y squared divided by 8. And the only way you're going to get good at this is to practice the problem. And what are we going to do with this? We're going to square it. dy, add them all up. And now we just have to figure out the y values. But you know, we kind of know it because we found the x was 2 and the x was 0. What are the y values going to be? If y equals x squared and x is 2, what's the y coordinate? No. Y equals x squared. What's the x? And x is 2. What's 2 squared? 4. So it starts at 0 and it goes to 4. Once you determine this, everything's determined. And the same goes when you do a u substitution. Once this changes to du, those limits of integration have to match that. Yeah, but I'm not going to do that. I want to get another one set up. This is the last kind. I'm hoping we're going to get it done. Okay? Well, we have to try to get it done because you will have problems like this. So first, we're going to put the axes in. We're not doing 5 today. That's the last lesson is 5. Okay, consider the region bounded by a curve, which I don't know what it is. The y-axis, okay, so the y-axis is this axis, and the line x equals -1. So here's x equals -1. I'll fix that in a second here. Okay, now here's the problem. X equals the square root of 4 minus y squared. What is that? Why is it a circle? If you square both sides, you get this. If you add y squared to both sides, you get, oops, that should be plus. X squared plus y squared equals 4. So it's a circle of radius 2. Now, this is not the top half of the circle. It's the right-hand side of the circle because it's x equals. So I'm going to cheat a little bit. There it is. Okay, there's my circle. I'm going to clone that. And I'm going to rotate that. Now this is rotated. This is an apple, if you think about it. It's rotated around x equals -1. Is that about right? It's the same as this figure right here, my model. And you guys have an apple core. This is like a little cylinder. You punch it through there, takes the core out, so then there's a hole in the middle of it, isn't there? And if you slice it, it looks like a CD. The hard part now is going to be getting the radius. So we're not leaving until we get the radius. So here's the inside. Here's the outside. Okay, you guys? Now this is where everybody really needs to listen. This is all geometry. I need to find the radius. It's pi, big radius squared, minus pi, little radius squared. Is it dx or dy?
Yes.
It's true. It is a yes. Which one is it, delta y or delta x? Delta y. It hits the y-axis. Quick way to check. Okay, let's do the radius. Because it's the same as this one. I'm going to take this circle, my apple, and well, that's why you practice.
How do you know it was the first slice of the apple?
It's any slice of the apple.
How do you know that X apple is?
How did I know it was a circle? Because I squared both sides, and I got y squared on the other side. X squared plus y squared is 4. That's a circle. We need to recognize that. Okay, you guys, we haven't done the hard part. What's the radius of, what's the little radius? They're not. This is not a function. What's the little radius? What's the little radius? 1. Now, here's the hard part. What's the big radius? I'm going to start at the axis of rotation and go to the original figure. This length here is 1. Everybody see that? Then, no. This length here is x. It's changing. It's not 4 here, is it? It's the x coordinate on that function. So what's the big radius? 1 plus x. Because it well, if it does, it only intersects once here. Always this does this. How about this? I want this distance right here. This distance. Is that the change in the y value, or is that the change in the x? It also hits the y-axis. Okay, your job is to finish setting this up because we ran out of time. You will, and try those AP problems because you're going to get a problem like this. It's not always plus the 1. It could be something else.